Let me know if you can see my screen. Yeah, right. Okay. So I would just recall the last topic, right? Why we were studying OLTP systems, specifically from the data perspective of data engineers. Okay, because data engineers usually start their career with OLAPs. Okay, they always start hearing about ELT, ETL, and since you guys working, all of them are working on Google Cloud, you might have heard a lot of services which Google Cloud provides, right? Data prompt, data flow, BigQuery, and then data flow templates are there, data proc workflows are there specifically for data proc. Apache Airflow, managed Apache Airflow is there. Then you know, GCP workflows are there. So these all are helping us to fetch the data from some system. Okay? That system can be uh, your OLTP systems, okay, or you consume the file somewhere. Okay. It could be an API, but behind an API again there would be some server or OLTP system only, or it could be an OLEP. But yeah, most probably if you are doing real streaming, it will be via wrapper through an API only on an OLTP system. So things become difficult, when people ask questions directly on OLTP, okay, because they expect that the person uh, should be aware of OLTP systems. And in interviews, you might go with understanding that okay, I am a data engineer. Why should I worry about OLTP system? Then you will be under shock that okay, OLTP systems are the stuff where everything starts from, and we cannot just go away with that. So this was a brief of OLTP system. In the previous session, Vamsi and Tejaswini, you can go through it. We went into the details of OLTP systems, specifically why it was needed, why it is row storage pattern. Third, it is acid, and there is lock mechanism for every row, page, and database level and table level. So all this has been discussed there, specifically the acid part, which is atomicity, uh, consistency, isolation, and durability. So today, if you think about this topic, this is part two, and this has to talk about normalization. Okay, because normalization uh, is the root of OLTP systems. Why is it a root of OLTP systems? How OLTP systems evolved, and why it was decided that we cannot keep the uh, details or input the details in a duplicated way. Like whatever comes, just store it. We should have to normalize it. Denormalization was the best way anyone could have followed, but what happened was everyone uh, was facing some of the issues. So, what are those specific issues we'll see, and what and why? Okay. So, database normalization is a systematic framework for organizing the data into a relational database. So, what is a relational database? Let's say MySQL, Postgres. Okay. So, normalization was a framework. So, everything has a framework, right? Uh, Even if you are planning something, you will plan accordingly, and that's how you proceed with your day or a trip. So similar for databases also. If people have to put in data, then there has to be a standard and framework which everybody across the globe should follow for their easy access. So what was the primary goal of OLTP? We discussed last time. It was low latency reads and write. Okay. If there is duplicacy, okay, if there is redundancy, a lot of redundancy, then low latency reads and write thing would go away, okay? Because of duplicacy, you will still keep a lot of data which is redundant, and you will not be uh, it will not be efficient enough. So I'll give you an example. Okay, so let's say we have one dimension. Okay, I will relate it from the dimension perspective, but you should understand it from a perspective of, let's say, the what, why, and where part of let's say a thing. That thing is, let's say we are talking about a product. Okay? So product uh, ID, okay, product name, product manufacturer, product country it belongs to, okay, product barcode, and whatever tells the the description of it. So there was a table, and people started duplicating every time whenever there was a change happening in the OLTP system. We are not talking about OLAP, so don't think around slowly changing dimensions and number of rows. We can do this, we can do that. So only thing from the perspective of OLTP, right? So they started duplicating the records. Okay? Uh, product ID one. Okay, A, product ID 1, product A, product ID 1. So whenever there was a change happening, they would keep increasing the rows. Okay, they were doing the same thing in OLTP system. So what happened was, then somebody asked that, okay, the name of the product is different. I have to update that name. So imagine if if that appended row is 100 times repeated in your table, you will update all those 100 rows, correct? Because it is append only. So if there was a mechanism, if we could have not duplicated it, we could have kept this particular thing somewhere, okay, and we could have mapped it like this is a product table, okay, and this is an order table. So whenever an order changes, okay, we don't need to change the product. So we are not combining product and order. We'll keep product separate, we'll keep order separate, we'll join them somehow. So that's how normalization came in. Okay. So normalization helped us in three ways specifically. It was to avoid update anomaly. Okay. It was to avoid your insert anomaly and to delete anomaly. So what are these anomalies exactly? So I explained you right away right now. So if we see from an example here, right? I hope my screen is clearly visible and you can read the examples. Uh, the example on the right side. If it is not, just let me know in the chat. Okay, all okay. You can read the example because I'll explain this from the example on the screen. So if you see, right, employee ID, employee name, department head, project ID, project role. So just a second. Now if you imagine, right, okay. So yeah, I hope this example is looking good enough, right? It's visible enough. Okay. So yeah, so employee ID, employee name, department name, project ID, project role. So what we did is we kept everything, right? We related everything from employee perspective, which is employee name, employee ID, department name, department head. It belongs, he belongs or she belongs to some department, and he and she could be in some other project, and the project role. If I talk about update anomaly, okay, and if I say that if let's say Anita leaves and is replaced as a department head, okay, so what would happen now? So Anita has left. Okay, so you have to update multiple rows because you have been keeping multiple rows. Why there are multiple rows? Because you kept two rows for Rahul because and Rahul wasn't working in two projects. Okay, Rahul was also working as an engineer somewhere, and Rahul was also working as a lead somewhere. Okay? Just to manage the role project role part of it. Now to talk about Sneha. Sneha's row is fine. Okay, but think from a perspective of department head. Okay, the moment department head changes, like I move Anita to Sunita, so I'll have to update these three records. And this is the part where update anomaly comes into picture. I don't want to update all these rows. I want to update it at one place, and this will refer at every other place through some mechanism. And that is what normalization forms will solve it for us. Okay. Then there was insertion anomaly. Okay. So if I want to insert a new department, I'll again have to do a redundancy. Now redundancy will be, let's say there is a department led by Vikram, which is name is security. Okay. So until you hire that employee, okay, which will be working in that department, you cannot add that row. Otherwise, those columns will be null. Okay. That doesn't make sense. Okay. So employee ID, since it is required, so cannot be done. So the problem is now you cannot insert a new row because of the department also. So if you want to add a new department, or let's say even if you want to add a new project also, not just a department. And if I talk about adding a new employee, then you are saying that okay, this employee is on bench, there is no department, there is no project for him. So you will keep nulls there. You might be thinking from a data engineering perspective right now that BigQueries and Redshift and other cloud data warehouses are so humongous and so capable of doing this thing that why I am thinking of it. I can keep nulls there. That is how we are doing it. But understand from the perspective of systems. So OLTP is completely normalized and OLAP is completely denormalized. They are built for denormalization. There we can do all of these things. We can keep nulls to reduce our storage cost and to reduce our query cost. Okay. But OLTP systems were actually meant for fast reads and writes. Okay. They were never meant for this purpose. Okay. So as a data engineer, when you work on OLTP system, and I'll 200% or 1000% guarantee you that in your future, which is right now 5 to 7 years, but in your future, somewhere down the line, right, you will have to interact with OLTP systems in one or another way, whether it will be agentic or whether it will be APIs that you will hit a OLTP system and fetch the data. Okay, it will be transactional based. It will be real time. Okay. So understand this from the perspective of OLTP systems only first, because you will be targeting your queries to OLTP systems. So now coming back to the topic, insertion anomaly we understood, update anomaly we understood. Now there is a deletion anomaly also. Let's say I want to delete a project, okay, or you want to delete Rahul, okay, and Sneha both, okay, because they have finished their projects. You will remove all the rows, right? You will remove the project. Okay, you will remove the department also. So you understood the problem. So I'll take a pause here. If you have any questions, you can put in the chat, like what is the problem here, and if you are understanding this from the perspective of OLTP system specifically. Any questions, right? Any questions? There has to be one question at least, specifically from the perspective of anomalies. Okay. Anyone want to take this? Any question? Shashidhar, Vignesh, Vamsi, anyone? Tejaswini? Okay. So I hope I have made it very clear what is the problem here. Okay. Keeping everything in one place will not solve the thing in OLTP systems. Okay, it is a big problem, so we cannot do that. Okay, so going forward, when we are not talking specifically about OLTP as in relational model, okay, that will be non-relational model. In that, you will hear that okay, there is a document model wherein we keep everything in the document. But OLTP non-relational models are built in such a way that they are efficient enough from that perspective. Okay. Right now, we are talking about relational models. Okay, so relational models need this type of table, manipulation, DMLs, and DDLs, and update insertion and whatnot. When we talk about non-relational OLTP systems, they specifically do all these things and get set, put, post. Everything is there. Okay, they are designed in a way that okay, their model is different. They can have nested structures, data structures are different. But since that was not part of the OLTP relational models, that's the problem. So right now, if you are also thinking about OLTP system non-relational model, just keep that aside, okay? Because we are not talking about that. So we are only talking about OLTP transactional models on relational side, which we all know as tables and databases. So if I go ahead, if you allow me to, so I would like to discuss on normalization forms. Okay, what are the normalization forms? So why we needed normalization forms? So see, everything has some categorization, and the way categorization works is we divide it into some layer. So we cannot directly just say that okay, this is something and this is something other thing. So we have to do categorization, and we could have directly jumped into the third normal form. But before that, we have to understand two and one also, because that is how it has been categorized. To to say, I would say it is the easiest way to categorize something. And why normal forms were needed is to solve these normally anomalies. Okay. So to decompose the large table into smaller tables and so that they can be linked via some relationship. So once they are linked via relationship, you can add a lot of stuff on top of it. So what is normal form? So normal form is first normal form, second normal form, and third normal form. So nobody is going to ask you what is normal form definition, but people will just specifically ask you normalization. Why normalization? So I hope that is clear. So type 1 normal form. Okay. So if I talk about type 1 normal form, it specifically says that every row, I'll repeat this, okay, because this is very confusing in the interview, okay. Your interviewer will try to target you, would say that, okay, whether it is a row or a column. Okay, so listen to this very carefully. Every row should be unique. Every row should be unique. So if I say unique row, it is A, B, C, D, E, F, G, H. Okay, it's unique. But if I would say A, it's not unique, because if you do distinct of it, you will only get one row. Okay. So row unique means all the columns they have different values in it. Okay. So both rows, if they are same, they will have the same values in it, and that will create duplicate row. So each record must be unique. One record must be unique. Every column must contain atomic values. Okay, what is the meaning of atomic value there? No comma separated. Okay, forget BigQuery here. Okay, don't think from the OLAP perspective. Okay, keep your stuff related to only OLTP. No comma separated, no arrays, nothing. Okay, no dot separated, nothing. We can do it because we are knowing it from the perspective of data warehouses. But no, don't think it that from that perspective. So if you see this example, right, this example right away is right now partially in first normal form. Okay, it is unique because it is only one row. It says 101 Rahul 555 and its numbers. Okay. Now, if I would like to make it into first normal form, I'll do two things. Sorry, one thing here. I will remove that non-atomic column and prepare an atomic column, and I'll duplicate that entry. Okay. Now, I already told you I had to remove the redundancy, right? And I am again doing keeping the redundancy, which means this is not normalized. This is first step of normalization. I have done the normalization, but it is still duplicating the data. Okay. 101, 101, Rahul, Rahul, 555, 01, 555, 02. Any questions on this particular space? First normal form. We have solved one part of it, but again we have created redundancy, which was not expected. Anyone? No? I'm audible, right? I guess you guys are hearing me. Guys, please collaborate. Okay, tell me something. If okay, if this I gave you, I will give you an example. So if this employee ID, name, phone numbers, okay, they were not, phone number was not comma separated. Okay, but let's say name was comma separated. Okay, name was comma separated. Then was it first normal form? No, right? Because we need uh, atomic columns. Okay, so atomic columns, nothing should be non-atomic. All the columns should be atomic. Okay? So atomic means no aggregated values, aggregated as in comma separated or any other way you will. So if I would explain from the perspective of your understanding how you think the data, what the data is saying. Right now you are seeing phone number as a column name, and then you are seeing two specific numbers separated by column. Sorry, number. If I say quantity, okay, okay. So if I would say products, okay, let's say we talk about Amazon, and let's say you placed an order, and Amazon keeps their data saved as okay. Vignesh had ordered something, and order IDs are order ID comma one, order ID comma two, order ID comma three, order ID comma four. So he has done four orders. These are comma separated. This may help probably in non-relational databases, but we are not talking about non-relational. In relational, this is yet not in first normal form. Okay. So what I did is I duplicated it. Duplicated means I repeated that record and kept a column atomic, and rest all thing is repeated. So first normal form was doing redundancy, which means there is a problem. So I have to go to another normal form. Now, second normal form says, okay, first normal form should be followed. I have to have unique rows and non-atomic columns. Unique row, full row should be unique, okay, and there should be non-atomic columns. Now it is saying all non-key attributes. What are the non-key attributes? If you have project ID and project name, so non-key attribute is project name. Okay. Key attribute is project ID. Think from primary key, foreign key perspective, or I would say OLTP system only. Think from perspective of a table. Project name cannot be a key. Okay? So all non-key attributes must be fully functionally dependent on entire primary key. So everybody is flat right now. What to understand from this part? Okay, this is the definition interviewer wants to hear from you. Okay, because they have been taught this way that okay, I want to hear this, and then they will say, okay, explain me from an example. How will you explain that? So I would say forget the uh, definition right now. Don't try to mug up the definition. If you mug up the definition, you will not remember the example. So understand it from the example, and then we will jump to the definition. So if you see on the side, right side, there is an example of employee ID, project ID, employee name, project name, and hours put in. So Rahul is working on project migration and API setup. There he has put in 40 hours. Okay. So hours here depend upon employee and project. Who put in 40 hours and in which project? Rahul put in 40 hours in migration project. Okay. Secondly, if you see employee name only depends upon employee ID. Okay. There is no other relation. Employee name and employee ID. I can relate it directly. Okay. But hours are related from two keys now. Okay, which is project and project name. Sorry, your employee ID and project name. Okay. So there is a problem here, which means there should not be any partial dependency. Okay. So we are solving the partial dependency. So we are saying one thing which is employee ID and employee name is actually related, which is fine. There is no other dependency in between. But for getting hours, I need employee and project name. So this is a composite key. So whenever there is a composite key coming into picture, okay, then there is a problem. Okay, which means there is a problem. It is still not in second normal form. Okay. So this table is in not second normal form. So if in an interview, how you will identify whether this is solved from the second normal form perspective or not? So they will give you an example and build this table. Okay. So you will have to first find out a column which is dependent upon two things. Okay? And you have to tell the interviewer that hours is actually dependent upon two things here, not just project. It is employee who is putting 40 hours in project migration. So whenever there is a composite key, it means it is not 2NF. So I'll have to make it into 2NF. Okay. How it will be 2NF? You have to solve the partial dependency. What you will do? You will keep one dependency separate, which is employee and employee name, other dependency separate, which is project and project name. Then you will build a third dependency, which is employee ID, project ID, and hours. That's it. Now, if I want to ask you, how many hours did Rahul put in total? So you will do two joins. Okay, you will join one which is will be on employee and project, and your join two will be project and your bridge table, which is a third table, employee, project, and hours. So with these two joins, you will do group by on employee, you will get summation of hours, which will be 60. Okay. You might again think I would have done it similar way in your first attempt only. I would have done Rahul group by Rahul and I would have got 60. But that is not the concern here. The concern is OLTP systems need some normalization. We will have to think from that perspective. Okay. So employee is one dependency which is solving employee name. Project plus employee is another composite key which is giving me hours. So I understood that composite keys always, you know, break the rule of second normal form, which is partial dependency. Okay. Partially, I know that Rahul has put in 40 hours somewhere. Partially, I know that in migration project there have been 40 hours. Who put in? I don't know. So I'll have to combine Rahul and migration to get 40 hours. So partially, I will not be getting to know exactly in which project Rahul spent 40 hours. Okay. So I'll have to compose it both the keys and then get the answer. But in second normal form, this is not allowed. So you will separate out two stuff: project, you will separate out employee, then you will create a bridge table which will solve employee 1, project 1, hours 40. Employee 1, project 2, hours 20. Clear enough? Now, can you understand the definition? Must be in first normal form, solved, right? All the tables, employee, project, uh, and bridge table, all of them are in first normal form. Records are unique. Yes, records are unique. There is atomicity in every column. Atomicity in every column. All non-key attributes must be fully functionally dependent. Rahul is only dependent upon 101. Migration is only dependent upon P1. AI setup is dependent upon P2. And when we talk about the combination, which is employee and project, we have a third table, and that table is telling me hours. Fantastic, we are done on entire primary. So entire primary key was employee plus project. Done. Any questions here? No. Deepti, Tejaswini, Vamsi. You can put in the chat. See, I'll not proceed on this without a question. Okay? I need one question actually. Because this is very confusing. How can anyone understand this from very first example? This is very confusing in an interview. You can add more columns on this example. Okay, the very first table, which is having 5 columns. Okay, and you can add, let's say, one more column, which is another dependency somewhere. No. Okay, so let me create one dependency here. Okay, so let me add project manager ID here, okay, as the last column. Correct. So redundancy, Vignesh, if you see, there is no redundancy, right? In all the three tables, employee, project, and the last bridge table, there is no redundancy. We are not we have not done any redundancy even in the bridge table. 101 P140 is not repeated. So we have to solve that redundancy, and we have solved it. Right? Good. If Rahul is working in 100 projects, okay, we will store Rahul 100 times. Correct. But that will be in the third table. Okay, that will be in the third table. But if you understand from the perspective of single table, which was above, you will have to have 100 rows. But now you have to have one row in employee, only one row or maybe 2 rows, okay, or 100 rows for project, okay, because those projects are 100. So you have to keep those 100 projects somewhere to get a dimension or the definition of it, which will be on P1, P2, P3, P4, P5 till P100. Okay. There is no redundancy. Redundancy is P1 migration, P1 migration. That is redundancy. If you are keeping it 2 times, then you keep 100 rows in your bridge table, which will be employee 101 P1, employee 101 P2, employee 101 P3. So all these rows are unique, and there is atomicity. First normal form satisfied. Every table has non-key attribute which are dependent upon only primary key. Okay, and their primary keys in the bridge table. If you are thinking about the bridge table has a primary key which is composite. Okay, in this bridge table there is no other value which I can get apart from hours. Okay, so that's why this is satisfying the ask of uh, second normal form. So I'll jump to my question wherein I was asking if there was manager ID, okay, employee ID, project ID, employee name, project name, hours, manager ID. What would have happened? Manager ID for Rahul would have been repeated there. 101, 10. Sorry. Let's say Rahul manager is Vignesh, and Vignesh employee ID is 102. So 102, 102 is duplicated there. So can you identify another, you know, so there would be one more table for manager and there will be one more bridge table for employee and manager, right? If we don't do that, we are keep will not be in first normal form. Why? First normal, sorry, we will not be in second normal form because second normal form says the dependency should be getting only one thing, which will be entirely on the primary key. Okay. Here the primary key in the first table that we are seeing is employee ID and project ID, which is giving me 40 hours. So that employee ID and project ID will never give me manager name. Manager is hardly tightly coupled to employee ID. For Rahul, the manager is Vignesh. So I'll create one more table for manager, which will be manager ID Vignesh, and there will be another bridge table, which will be employee and its manager. Okay, good enough. Proceed. Vignesh, your question has been answered for redundancy. Okay, sure. So this is also not solving one more problem. So there are many normal form, but people stop at third normal form because normalizing too much is also a problem. So everything is having their own problems. So no transitive dependencies. Again, a definition. Okay. Don't try to learn a definition. Learn one line words. No partial dependency. Okay. No transitive dependency. Okay. And in first normal form, we said unique atomic values. Okay. Unique records and atomic values. No partial dependency. No transitive dependency. That's it. So now transitive dependency, I will not try to explain from the definition. I will explain from the example. Now example says employee ID, employee name, department ID, department location. So department location depends upon department ID, and department ID depends upon employee ID. Okay. So I can get from employee, okay, I can get his department location via department ID. So the transitive thing is from A I got B, then I got C. So I am getting A. If I know A, I'll get B. From B, I'll get C. Okay. So no transitive dependencies means no non-key attribute. So non-key attribute must depend only on primary key. So non-key attributes are what? In this table, non-key attributes are department location and employee name. Okay. So non-key attribute must depend only on primary key and not on other non-key attributes. Okay. So the thing is, employee name is a non-key attribute. It should only be dependent upon employee ID, not department ID. Okay. Then there is another non-key attribute, which is department location, which is only dependent upon department ID. So because department location relies primarily, through another column, this is the problem. We should not have transitive relationship A to B to C. Okay. To solve this, move something to a lookup table. Okay. So one table is fine that okay, employee this works in a department ID with a foreign key relationship that employee 101 works in department D1. Employee 102 also works in department D1. Okay. And then we link both these tables via foreign key. And we say, okay, department 1 is Pune. Now, are we solving it from the perspective of second normal form, which was no partial dependency? Is there any partial dependency here yet? No. Department ID department location solved. Then employee ID, employee name, okay, one thing. But which department? So it is solving the problem of partial dependency also, that it is not partially dependent. Rahul works in department D1 and his employee name is Rahul. So employee ID and department ID is solving the second normal form also, that whatever non-key attributes are there, they are not partially dependent upon anyone. So can you tell me that in department 1, Rahul or Sneha is there if there was no employee ID in the second table? No. Okay. So there we have to add one more key which will be composite, and it will be telling me clearly that okay, employee ID 101, department ID D1, Rahul. Employee ID 102, department ID D1, Sneha. So with this, we covered three normal forms, but start with one full example where we'll see the problem and we'll try to solve it till normal form third. Okay. What are Whether it is actually in first normal form or not. Okay. So first you see the problem and you tell me whether this is first solved via first normal form or not. Don't see the answer on the left side. You think about it, the problem, and then this tell me. So I rushed from third normal form to here because I wanted you to understand from the example that whether this is first normal form, then we'll jump to second, then we'll convert into third. Okay. So how we'll do that. So don't see the solution, just see the problem right now. The problem is appointment. This is patient and doctor's uh, design, wherein appointment has been taken by a patient with this doctor name, doctor specialty, doctor phone, and date. So first of all, the anomalies. If I want to delete a doctor, I delete whole row. If I want to add a doctor, I will have to repeat nulls for other stuff. Update also the same thing. I'll have to update a lot of those. So anomalies are there, which means it has to be normalized. So first of all, whether this is first normal form or not, you have to tell me. Vamsi, whether this is first normal form, the problem itself, whether it is in first normal form, yes or no. This is in first normal form. Why? Because there are all atomic columns and each row is unique. See, there is no duplicacy. Three rows all have 101, 102, 103, which means if one column itself is not repeating, we should not go to another column to see the duplicacy, right? We see the duplicacy starting from the first column. Let's say if our appointment ID 101 was repeated three times, then we would have seen, okay, John Doe is repeated three times. Then we would have seen, okay, Dr. ID is repeated three times. Okay, so which means unique rows or atomic first normal form satisfied. Is this in second normal form? Anyone want to take this? Is this in second normal form? Correct, unique values. Good. Is this in second normal form? Who wants to take this? So first normal form is already satisfied. So the rule of second normal form is it should be in first normal form, correct? And then there should be no partial dependencies. So are there any partial dependencies here? This is very the moment when you see a lot of composite keys. But I'll wait for you to answer. What all composite keys are here? And why this is in second normal form? Because answer says this is already in second normal form. How? Think about it. Partially, can I get anything? Shashidhar, Tejaswani, can I get anything partially here? See, I'll always get doctor name from doctor ID. Okay, correct. For the appointment date, okay. If the appointment ID is 101, I'll always get 0108 2026. Okay. So there is no partial dependency for date. For phone number, if I want to get doctor's phone number, I don't need patient name, I don't need appointment ID. I can get it from doctor ID. I'll enter D50, I'll get 555 1234. But there is a catch here. Now you think I'll get two rows. Okay? There's a catch here. But that is still okay till second normal form. Second normal form says no partial dependency. So patient name, you tell me patient name, can I get it from appointment ID? Yes. One appointment ID is giving me one patient name, right? Jane Doe, John Doe, and again John Doe is giving me appointment. Via appointment ID, it is giving me patient name. Is there any composite key which is completely unique and giving me something, and I can also break that and still get the same value? For example, there are 1, 2, 3, 4, 5, 6, 7 columns, and I join first six and I get the seventh column. And then I break the first six columns and still get the seventh column. Is there a way? Vignesh, this is very confusing. This is actually very confusing when this comes into your interview problem and they ask you whether this data is second normal form. So you don't have to think too much. Okay, you have to pick one column and see that whether it is a key attribute or a non-key attribute. If it is a key attribute, keep it separate. Second normal form says only one thing. Actually, it says two things, but which is first we have already satisfied. All non-key attributes. So we'll not talk about key attributes. All non-key attributes must be fully functionally dependent upon entire primary key. That's it. So all non-key attribute: patient name, doctor specialty, doctor phone, and date. So we'll talk about patient name. Vignesh, is it dependent upon appointment ID? Patient name, yes or no? Quickly, very quick. Which composite key? Patient name is dependent upon which composite key? Patient has taken an appointment, right? So I can tell from appointment 101 the patient is John Doe. Is there any other composite key? No composite key. Okay, so you are saying no composite key. Okay, which is fine. Appointment ID we are getting. Both tables use a single column primary key. There is no part. Both table we are talking about only one table. Vamsi, right now. There is no another table. There is a solution actually. So solution we'll discuss later. I'm talking about this problem table. Does it have any problem for second normal form? So we'll talk about non key columns, which are non-key, non-attribute key columns, which are attribute columns. So patient name, doctor specialty, doctor phone, date. Coming to doctor name, can I get from a doctor ID? Yes, right. I don't need any composite key to get doctor name, right? Even if it will be one unique primary key. You cannot divide that and still get it. Correct. Not composite key. Okay, so I guess you got an idea that any non-key attribute should be entirely dependent upon the primary key. Your primary key can be composite, but if you divide that composite key, you should not get that column again. If you are getting it, it is still not in the second normal form. So now we'll jump to third normal form. So is it in third normal form? There is any transitive dependency here? I see a lot of transitive dependencies. That from appointment I can get doctor ID, and from doctor ID I can get doctor name, right? This is a transitive dependency. 100% there is a transitive dependency. From appointment ID I got, doctor ID, and from doctor ID I got doctor phone number, which means it needs a solution, right? what kind of a solution it needs. So we have to think from a perspective that what all columns are causing this. Okay, so doctor is one which is causing the problem. So let's take out all the columns of doctor separately. Okay, so all that four columns I have taken separately: doctor ID, doctor name, doctor specialty, and doctor phone. All four columns separately. Okay. Now, if you see, only columns remaining are appointment ID, patient name, date, and then there is a reference of doctor ID. That this appointment, this patient is looked up by doctor 50, which is Dr. Smith, which is their ID. So now these two tables, are they in first normal form? Yes, all are unique records and they are atomic. Cool. Is there any partial dependency here? Non-key columns. Non-key columns. Patient name and date. Can I get patient name from appointment ID? Yes. Can I get patient name from doctor and appointment ID? Yes. But I cannot get the patient name from doctor ID itself. So appointment ID plus doctor ID is equal to patient name. But only doctor ID will not give me a unique patient name, which is it will give me two, John Doe and Jane Doe. So it is not dependent. Okay, so which means we have solved the problem of second normal form. So it is not partially dependent. Okay, so partially doctor ID is not giving me the patient name. Is it clear now that I can get the patient name, which is a non-key attribute, from appointment ID? Okay, one, I can get the patient name from appointment ID and doctor ID, but can I get the patient name only from doctor ID? Anyone wants to take this? Can I get the patient name directly from doctor ID? I can get, but there is a problem here. What is the problem? Vamsi, what's the problem? I can get doctor ID. Sorry, I can get patient name from doctor ID. I'll say where doctor ID equals 50. What will happen? Will I get one patient or two patients? One too many. Correct. So, which means it is already solving the problem that doctor ID will not give me one unique patient, which means I have solved the problem. It is in second normal form. Composite key cannot be divided and still get the non-key attribute. Okay. Date. Okay. Appointment. I enter 101. I get the date. Okay. Appointment A0102. I get the date. Appointment plus patient plus doctor. I get the date. Can I get the date from patient name? John Doe has two appointments. No, I cannot do that. So I divided the composite key and I thought that okay, patient and doctor can give me the date. Can? No. John Doe with Doctor 50 can have a third or fourth appointment on another date. We are seeing John Doe repeated twice. Imagine there is instead of Jane Doe, it is John Doe with the same doctor D50, and there is a third appointment. You cannot get that. So we'll get three rows. Okay. So even if patient and doctor you combine, you uh, broke the composite key into various combinations, but still you're not getting it. So which means this table is already in second normal form and it's already in third normal form. So I hope this particular stuff helped you right to understand in detail. You can write yes, no, any questions. So we are end with this topic. Okay, we have ended this topic OLTP systems. We have done understood what our OLTP system, what was the history, why we needed it. We started with that. Uh, we understood row locking, we understood concurrency, we touched based on distributed systems. We talked about concurrency also. We talked about atomicity, consistency, isolation, durability. You can relate all of this to Google Cloud SQL, which gives uh, a lot of, uh, I would say, not a lot of, it gives 4 to 5 flavors, which is SQL, MySQL, then PostgreSQL, Oracle, it gives. Uh, then there is one more, I don't remember the exact name. Uh, Maybe SQL Server also, but there is paid version, I guess. So free versions are only MySQL. Free as in it's not free, but you don't need to buy the license because it is open source. So yeah, Postgres and MySQL specifically. So if you are not on GCP first of all, so I would request that make up your mind that you have to use GCP via your personal IDs, because without you know doing the practice, you will not know anything. Okay. So I would keep checking with you on WhatsApp for creating an account. If you don't even have free credits, right? We'll do something to understand OLTP on BigQuery somehow. We'll have to do that because BigQuery is mix of OLTP and data warehousing OLAP. So it gives all that. So big and run and all that. So it's a mixed warehouse. So free tier BigQuery we can do stuff. We can understand all this stuff. Okay? Normalization we can create all the tables and small, you know, project for you, which will be 5 tables joined, and then you will try to solve the queries yourself from an e-commerce or retail or digital, any other stuff marketing. So, any questions specifically? Last 5 minutes, we'll take a question and we'll switch this off. And how was the session? No questions, no reviews, good, bad, nothing. Okay, session went good. Okay, thank you. Let's keep meeting. Next, what we'll discuss. Okay, so I'll ask you guys whether you actually want to deep dive into distributed systems now or OLAP. So you have two options. You have two options. We can do distributed systems and we can also do OLAP directly. Data modeling, OLAP, or you want to understand distributed. Distributed systems will help you to relate this particular topic with distributed system, because in distributed systems the interviewer will actually ask you from the perspective of OLTP only, because the rest of the distributed systems things that you already know is already managed and given by some cloud. BigQuery, Redshift, uh, another vendor is Azure, right? Azure has Synapse. Okay, so all that thing you get in managed as distributed system. You don't even think about how it would be implemented, but if you want to understand in depth how they would have built it, uh, they would have built a totally separate layer on top of it. It would not be a OLTP system specifically because they are building warehouses, but the base remains the same, understanding remains the same, and distributed systems is the actual ask in the market right now. So people will grill you specifically on distributed once you grow, right? So I would actually also want to know what is your all experience right now. Can I say that all of you are under 7 years of experience? So I'll name Vignesh, Vamsi, I know Deepti, I know under seven. Tejaswini, I don't know whether you are under seven. Shashidhar also I don't know. And I forgot one. Navneet. Has Navneet joined today? Yes or no? Sorry, Navneet, if I have joined. So under seven, Shashidhar, you have or you are also under seven. Okay. So how much experience do you have, Shashidhar? I don't know about you. So why I'm asking is the moment you shift the gear, okay, and move from seven above. Sanjay, who is Sanjay? It has to be Navneet, right? Okay, so somewhere between 4 to 5. Okay, 4.5. So I'm telling you, so 5 to 7 is still okay. You'll be asked SQL more, cloud more, services more, what you have done. But these sessions will actually help you more when go from 7 to 9, because with AI, they expect more that AI can help you. So you should know at least this thing and how will you implement the stuff. They don't want to actually implement, but they want you to tell them how will you implement it, at least the theory. The theory actually helps. So these types of session will actually help you. Vamsi, for you, I know it's uh, nice journey starting from the query, and then even Vignesh. But yeah, keep it up. um, it's a good thing. Then distributed, then probably, yeah, we can do data modeling, because data modeling is in under our collab, and then we'll start with data modeling, because distributed system, it will you'll get a lot of curiosity from how, specifically on how it was done before cloud. Okay, how things people would be doing this before cloud, how they would be scaling it. Now you can scale uh, at a very fast pace. Okay, like you can just hit a Terraform script and you have five OLTP RDBMS ready for you. But then replication, partitioning, all those comes into picture. So you need to understand from that perspective. So pre-cloud, what would have been happening, and then in cloud the services we have, and how high availability helps. So okay, we'll do. So I'll do one thing. I'll schedule Saturday, which will be 15 August को तो नहीं कर सकते. It is 15th of August. I'll skip 15th August. Uh, I'll try to see if it's 16th. I'll let you know on the group, uh, community group. I'll let you know. But we'll do distributed system. Done. Okay. With this, bye bye. Have a happy weekend. Bye bye, guys. So, Vignesh, please add Sanjay to that group. Okay. Thank you. Bye.